In this lesson, we are going to talk about dimensional analysis. All right, before we get into dimensional analysis, the first thing we should know is that there exists base quantities that provide units for all other physical quantities to be expressed in. So what are these base quantities? These base quantities are usually mass, length, and time. Now, if you're still confused, that's okay. Let me break it down for you in another sense. Here we have velocity. Now the formula for velocity is equal to distance over time. Now, if we come back to our three base quantities, mass, length, and time, the thing we should note is that distance, it can be expressed in length, and time can be expressed in time. So therefore, velocity can be expressed in LT negative 1 or L over T. Now, I want you to pause the video and do the same for force, which is equal to mass times acceleration. And once you figure that out, or if you're confused, continue the video. All right. Again, we have our three units. Mass is expressed in terms of m, and acceleration is equal to distance over time, which is the velocity, all over the time again. So this means acceleration can be expressed in LT negative 2. This means force can be expressed as MLT negative 2. Now, we call a quantity with dimensions M0, L0, T0 dimensionless. Or in other words, we can say an equation that is true regardless of the units is called dimensionally homogeneous. For an equation to be dimensionally homogeneous, the dimensions of all terms must be the same. And to achieve this, we come back here and attempt to get a mathematical model where all the possible dimensionless products are among the variables. And this here is called a complete set. Now let's do an example question. Let's say we have a simple pendulum like this, where we have a length r for the string, a theta value, and a mass m here. So we know mass is equal to m, we know length is equal to r, we know angle of initial displacement is equal to theta, and we know G denotes gravitational acceleration. Now, using these four values, we want to find the period tau of oscillations. This means we want to find tau is equal to FR m theta g, where tau is a dependent variable. Now to begin this problem, let's start by outlining our variables and the dimensions of each one. First off, we have tau. Now tau represents the period of oscillations, which means it will just have a dimension time for period. Next up, we have the length of the string, which is just L. Next, we have m, which again is just m for mass. Now gravity is equal to acceleration. If we remember, acceleration is equal to velocity over time, where velocity was equal to LT negative 1 for distance over time. So therefore, acceleration is equal to LT negative 2. Finally, we have theta. Now theta is completely independent of mass, length, and time. So it'll just be 1, or m0, l0, t0. Now, a product of these 5 variables will be in the form RB, MC, theta d, GE, where A, B, C, D, E are just numbers. Now, when you simplify this to dimensions, it becomes TA, LB, MC, M0, L0, T0, D, LT negative 2E. This can again be simplified to MC, LB plus E, because we gathered the L from the B here and the L from the E here, and T, A minus 2E, because we gathered the A from here and negative 2E from here. Now, for this dimensions product to be dimensionless, we have to have C, B plus E, and A minus 2E all equal 0. So therefore, we set C equal to 0, we set A minus 2E equal to 0, and we set B plus E equal to 0. Using these, we can find E is equal to A on 2 from this equation. We can find B is equal to negative A on 2. And D, which is not in any of the equations, is just 3. This means we can simplify this initial product of the variables, tau A, RB, MC, theta D, GE, to tau A, R negative A on 2 from here, M0, because C is equal to 0 as we gathered there, theta D, as D is just 3, and G A on 2. Now this can be simplified to tau R negative half, G half, A theta D, which can finally be simplified to this, G on R, A theta D. We then want to get the independent dimensionless products from this, which would be G on R and is equal to theta, where this represents just an independent dimensionless product. Alright, now let's do a proper question. Here we're told that the speed of sound in gas depends on the pressure and density. Now, before you pause this question and do this yourself, if you don't know the density and the pressure units, it's okay for now, but I recommend you remember it for whatever you're studying for, if you have an exam coming up, etc. In the original question posted, the pressure and density were actually given the units. So here I'll give you the units for pressure, which is equal to kilograms a meter a second, -2, and density, which is equal to kilogram a meter -cubed. Now feel free to pause the video and try the question yourself. If you ever get stuck, just unpause and we'll go through the question together. Alright, so the first thing we should do whenever we're given a dimensionless analysis question is find the things we're trying to find in terms of the mass, length, and time. So we know P, pressure, is equal to m L -1 T -2, because it was given that pressure has units of kilograms a meter a second -2. I should also note that these brackets around the P just mean the dimensions of P. Now, we can also do the same for density, which would be ml -3. Now, note this value here for density is not the same as the big P in pressure. This is actually called rho. It's a Greek letter, but that's not relevant. Finally, we have velocity, or the speed of sound, v, which would just be lt -1 for distance over time. Now, like we did in the pendulum question, what we want to do is get a dimensionless product of these variables. So we want to find VA, PB, rho C, which would equal LT -1 ML to the power of A, T -2B, ML -3C. This can be simplified to MB plus C, L A minus B minus 3C, T -A minus B. Now we want to equate this to M0 L0 T0. So when we do this, we get the simultaneous equations B plus C equals 0 from the M, A minus B minus 3C is equal to 0 from the L, and -A minus B is equal to 0 from the T. Now, your first instinct might be to solve these simultaneous equations. You have 3 unknowns, 3 equations, but I'll show you what happens if we try to do that. Now, here we have B plus C, so B is equal to -C. We sub this into the third equation, we get -A plus 2C is equal to 0, so A is equal to 2C. Then we sub these two into the second equation, we get 2C plus C minus 3C, which is equal to 0. So 3C minus 3C is equal to 0, so 0 is equal to 0. So effectively, we haven't solved for C, so therefore we can't solve for A and we can't solve for B. Now, the actual idea here is just to choose a value for A. This seems counterintuitive and this seems a bit confusing at first, to just choose a random number for A, but usually you should have an idea of a number you choose for A, which would simplify the process. So in this case, we have a 2 for the B, so we would want to make the A, let's say, just 2. So therefore, we got -2 minus 2B is equal to 0, so B is equal to -1. That means C would equal to 1. Now, if we sub this back into our original equation for VA, PB, rho C, now we would just get from this that V squared P -1 rho 1 is dimensionless. Now, we're not done just yet, because we can set this to a dimensionless constant k. So we set this to a dimensionless constant k. Which leads to a relation V is equal to root K pressure over rho, which is equal to K pressure over rho, where K is equal to root K. Now, if you're a bit confused about how this equation worked, say we had V squared P negative 1 rho 1 is equal to 1. So therefore V squared is equal to P over rho. So V is equal to root P on rho. That's how that was calculated. And then K is just a dimensionless constant which you include in your final answers. Now, hopefully you enjoyed this introduction to dimensional analysis. Let's quickly just run through what we've learned today. So the main takeaway from this is that many things can be expressed in M, L, and T, where M is mass, L is length, T is time. Our goal is to make it a dimensionless product as shown. I would also highly encourage that you remember that pressure is equal to kilograms a meter negative seconds negative 2, and density is equal to kilograms meters negative 3. Depending on your university, this could easily change if they decide to be nice and give you these, or just throw you a curveball and not give them to you and expect you to remember them. I would also make sure you just remember this basic formula: F is equal to ma. Now, I will be making a part 2 on dimensional analysis where I'll be running through more complicated questions, so stay tuned for that.